This has got a D term, okay? That +1 is the vertical shift. All right, and it's really the most minor, the simplest one of all. All right, amplitude is what here? 1/2. Period? 2 pi. Frequency? 1/2 pi. Phase shift? X equals -pi. All right. Yes.
What is the frequency? Can you use it?
No. Right. So now let's see from where to where we're going to put our points. 0, x plus pi, 2 pi. So this goes from -pi to x to pi. And again, the distance from -pi to pi is 2 pi, which is what our period is. So we're going to go -pi, 1, 2, 3, 4, pi. The middle is 0, pi over -pi over 2, positive pi over 2. And clearly the y-axis is here. Okay. Okay. Correct. Because the number in front of x is, which is b, is 1. So it's 2 pi over 1. So it's 2 pi. Okay. Okay, now we're gonna graph a sine. It's got a vertical shift, all right? So it's got a vertical shift of 1. Now this is 1, and that's 2. If it's got a vertical shift of 1, that means everything gets moved up by 1. So you go to y equals 1, and you put a dashed line like this at y equals 1. All right? And now that's your axis of oscillation. So from that blue axis, we're going to go up and down. All right? So remember when we're going to start at -pi? At -pi, we're on the axis. And then we go up 1/2 on the axis, down 1/2 on the axis. So it looks nice and cute like that. Okay? Right? So, does it meet all the requirements? It's shifted up by 1. It's got an amplitude of 1/2. It's got a period of 2 pi. And it's shifted to the left by -pi. Okay? Now, can we put it all together and go backwards? Here is a graph, and we need to find the equation for it. The first thing you have to do is split it down the middle horizontally. So here, split it down the middle exactly. Too often, students don't do that, and then it's all a mess. Okay? Once you do that, okay, is this a sine or a cosine graph? It's a sine graph. What is the amplitude? That distance, 1, 2, 3, 4. So A is equal to 4. Now, how much is the period? So one cycle, it completes one cycle over a length of 4 pi. So, yes, so look, I drew one cycle, right? And it went to 4. So period is 4 pi. 2 pi over b is the period, and that's 4 pi. So how much is b? B is 1/2. Okay, is there a vertical shift? Is there a phase shift, horizontal phase shift? No. Is there a vertical shift?
Yeah.
How much? -2. So, y equals a sine bx plus c plus d. Y equals a, which is 4, sine half x. There is no c. Don't put +0, please. And then it's plus d, which is -2. Now, if you leave it like that, it's understood, if there are no parentheses, it's understood that the -2 is your d. If you went and put parentheses like this, no good, because now the -2 became a C. If you put parentheses like this, that's okay. So either those or none at all. You can, but it's not conventional. All right, now I'm going to need your help for this next one. We've got a function that has a period of 4 pi. And it's got an amplitude of 2. And it passes through the point pi comma 2. Now, if the period is 4 pi and you don't know, you haven't seen the graph. Remember, period is 2 pi over b is 4 pi. Period is technically 2 pi over absolute value of b. So, b in this case, absolute value of b is a half. So, b can be a half or a -half. So now it's up to you to figure out, is it the half or is it the -half, right? So it's y equals a sine x or cosine x. We don't know. So now what I'm going to do is I'm going to stop this for 2 minutes, and your period is based on. So it's going to be y equals a sine or cosine half of something, because b is a half. All right, now, when the period is pi, we're at 2. So it's going to be sine half of something, right, times x. So let's try that one. So let's put in what we have. Y is equal to 2 sine half x. Let's see if that works. Now when x is pi, right? What's sine of pi over 2? 1. 2 times 1 is 2. So this is the one that works. Okay? Yeah, you have to plug in the x and y to check. Okay,